section 5.31. So what we're doing in this section is the idea, the main point is we're going to solve equations that involve trig functions just like we've done in algebra. So we have some kind of equation that involves trig functions. So we're using all of our algebra techniques for solving equations. We might have to factor, we might have to subtract things from both sides, we might have to divide, whatever. But we're also going to end up using our techniques from trigonometry, like maybe manipulating the equations with identities. And in the end, we are going to, usually when we're solving equations, the way that they're set up for what we're doing is the solutions are going to be nice, meaning that we can use our unit circle to figure out what our solutions are. So just when we're working with trig equations, our bottom line, kind of our big rule is we want to isolate the trig function. And I'm going to put an S here because sometimes there might be more than one. Isolate the trig functions, meaning get it on one side of the equation. And everything else on the other side. So the numbers on the other side. So we're trying to isolate. We're solving for the trig function, where normally we would solve for x or y or whatever our variable is. Here we're solving for the trig function. And then we end up, what we want to do, the solution is we want to find all the angles, because we have a trig function. We want to find all angles that make the equation true. And the reason that we emphasize all angles is because we want to include all coterminal angles also. So basically what we're talking about is we find a solution, we find solutions on our unit circle and any multiple of 2 pi. We can go around the circle again and get to the same angle that's still going to solve our equation. So what I'm going to do today, kind of like we've done the last couple of days, is just do several examples of several different kinds of trig equations, so you see some examples of the types of equations that you might see. But this is the bottom line, what we're trying to do. And we're using algebra techniques that we already know, and we can use the trig techniques that we've been working on. All right. So, first one, we'll start with an easy one. We're going to solve, and all of these we're solving. So I'm not going to write that each time. Solve 1 minus 2 cosine x equals 0. So what we want to do is get our trig function by itself on one side of the equal sign. So I'm going to add cosine x to both sides. So I get, add 2 cosine x to both sides. So 2 cosine x equals 1. I just added 2 cosine x to both sides, turn my equation around. Divide by 2. So cosine x equals 1/2. Now we want to find all angles. We want all angles, or all x values, where cosine x equals 1/2. So we would go to our handy little unit circle and look at our x coordinates. Cosine is the x coordinate, where it equals 1/2. I get pi over 3. and 5 pi over 3. Cosine of my angle is 1/2 at pi over 3 and 5 pi over 3. So I go back to my equation. So x equals pi over 3, and I'm going to leave a space here, or 5 pi over 3 that's where my cosine is 1/2, but any coterminal angle will also work. Coterminal angle is going to be any multiple of 2 pi, and the way we write that is pi over 3 plus 2n pi, where n is just an integer, 1, 2, 3, 4, 5, -1, -2, -3. So the 2n pi just takes us around the unit circle more and more and more times. So my solutions for this equation are x equals pi over 3 plus 2n pi, or x equals 5 pi over 3 plus 2n pi. These angles, or any coterminal angle, would solve this equation. Does that make sense? All right. Let's look at tangent squared x minus 3 equals 0. So we want to solve this for x. So our first step, isolate the trig function, get it by itself. So I'm going to add 3 to both sides. I get tangent squared x equals 3. To solve for tangent x, what do I need to do? Square root. Take the square root of both sides. So tangent x equals, and we have to be careful here, square root 3 plus or minus. I can have a positive or a negative square root. So when I take the square root of both sides, I can get a positive or a negative solution. And now we need to look on our unit circle. We need to figure out where tangent of x is square root of 3. So we go to our unit circle. Tangent of x is sine of x over cosine of x. So we need the y value divided by the x value to be square root of 3. So we'd be here at pi over 3. And over here at 4 pi over 3 would give me a tangent of square root of 3. So we go back to our problem, and this tells us that x equals pi over 3. And what is the period of tangent? Pi. So we can add a multiple of pi to tangent, because tangent repeats every pi units. So x would be pi over 3 plus n pi. That would get my pi over 3, that would get my positive square roots of 3. And I also look at my unit circle where the tangent is negative square root of 3. So let me go back to the unit circle. Negative square root of 3, I would be down here at 5 pi over 3, or over here at 2 pi over 3. If I divide the sine by the cosine here, I get negative square root of 3. So if I take 2 pi over 3 and add any multiple of pi, that's going to get my negative square roots of 3. So x is going to be 2 pi over 3 plus some multiple of pi. We're adding a multiple of pi for the tangent because the period of tangent is pi. So the tangent repeats every pi units around the unit circle. So this will get all of my angles where the tangent is plus square root of 3 and where the tangent is minus square root. Questions on that one? All right, let's look at a slightly different example. So these are kind of like one-step equations where we just are adding or subtracting to get everything by itself. Remember, when we take a square root, we get a plus or a minus. Always get a plus or a minus square root. And for sines and cosines, we're adding multiples of 2 pi. For tangents, cotangent, we're adding multiples of pi, because the period of tangent and cotangent is pi. All right, so we're still solving. We're going to solve secant x, cosecant x equals cosecant x. So what do you think is going to be our first step for solving this equation? All right, so I had two different things. Melissa said get everything on one side. Alex says divide by cosecant x. So let me talk about what Alex just said. So if we had an equation that said, let's say 3x equals x. And we wanted to solve for x. What would we do with this equation? We will just subtract the x. So we would get 2x equals 0, or x equals 0. If I divide by the x, I'm losing. I would say that 2x. If I divide by the x, I would get 3 equals. If I divided by x, 3 equals 1. Right? If I divided this equation by x, I would get 3 equals 1, and that doesn't make sense. So on these, we're going to subtract the cosecant to get everything on one side. Question, Colin? Okay. So I'm going to say that this is secant x, cosecant x, minus cosecant x equals 0. Now what can I do with this? The cosecants, well, this would be like, this is multiplied, so what can I do with this cosecant? I can factor. It's common to each term, so I can factor. So I'm going to write this as cosecant x times secant x minus 1 equals 0. Now when I have two things that are multiplied together and it equals 0, what does that tell me about these two things? What if I had, let me write over here, if I had x times x minus 1 equals 0, how would I solve this? Well, we just factored. So I don't want to distribute because I would redo what I just did. If I have an equation like this, if two numbers are multiplied together and I get 0, what does one of the numbers have to be? 0. So this tells me x equals 0 or x minus 1 equals 0. One of these two has to be 0 for them multiplied together to be 0. So for this to equal 0, for this product to equal 0, this tells me that the cosecant of x equals 0 or secant x minus 1 equals 0. This problem here is exactly the same as this one here. When I have two numbers that are multiplied together and they equal 0, one or the other has to equal 0. That's the only way I can get 0 when I'm multiplied. The cosecant of x, what is cosecant in terms of sines and cosines? This is 1 over sine x equals 0. Does 1 over sine x ever equal 0? No. For this to equal 0, the numerator has to equal 0. So this doesn't give me a solution. And this shouldn't be 1, this should be 0. So the secant of x has to equal 0. So I'm going to go with this one. Secant of x equals 1. So the secant of x has to equal 1, and the secant is 1 over cosine x, that equals 1. When is 1 over cosine x going to equal 1 on our unit circle? X equals cosine is 1. You're thinking sine. Where's the cosine 1 on our unit circle? At pi, it's negative 1. So it would be 1 at 0, or what's another name for 0? 2 pi. So x equals 2 in pi, any multiple of 2 pi. So the solution to this equation would be any multiple of 2 pi, 2n pi. And remember, the thing that I want you to take away from, the two things that I want you to take away from this equation: we don't divide by cosecant x, and when I have parentheses that are multiplied, one of the two things, they equal 0, one of the two things has to equal 0. It's just like this equation, just like solving this equation. All right, questions on that example? Okay, let's look at another one. So these next examples are quadratic examples. So we're going to solve 2 cosine squared x. We're still solving 2 cosine squared x plus cosine x minus 1 equals 0. Any idea how we go about this? So I heard two things. I said bring the one over, and I heard factor. If I bring the 1 over, I still have a cosine and a cosine squared, so that really doesn't help us. So let me write this over here in blue. I'm going to write 2x squared plus x minus 1 equals 0. We would solve this by factoring. So how would we factor 2x squared plus x minus 1 equals 0? I know I have a 2x and an x, and I have to have a 1 and a 1. So how do my signs have to go? Plus and minus? Minus and plus. So this would give me 2x squared. This would give me a positive 2x minus x would give me a positive x. And these last two would give me the negative 1. So this problem is exactly the same. I have to factor this problem just like I factor this problem. So this is going to be 2 cosine x minus 1 times cosine x plus 1. And that equals 0. And for these, for this product, for these two parentheses to multiply to give me 0, one or the other of them has to be 0. So this tells me that 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. So I have two problems. Now I have two problems that I have to solve. This one tells me that cosine x equals 1/2. This one tells me that cosine x equals minus 1. I look on my unit circle for where cosine x equals 1/2, and I would see that x equals pi over 3 plus any multiple, or x equals 5 pi over 3. So I'm just looking on my unit circle, finding where cosine of x is 1/2, where my x coordinate is 1/2, and adding multiples of 2 pi. Cosine of x equals -1. We just talked about where it equals +1. It equals -1 at x equals pi plus 2n pi. So any multiple of pi. So for this equation, we end up with three solutions. Pi over 3 plus any multiple, 5 pi over 3 plus any multiple, and pi plus any multiple, 2 pi. And we solved it by factor. Questions on that example? All right, I have two more examples that I want to do. Another quadratic and one with a multiple angle. So on this one, we have a little bit more work to do. For this one, we're going to do 2 cosine squared x plus 3 sine x minus 3 equals 0. So looking at this, what is, if we're thinking about this, what is there something that you don't like about this one, other than its trigonometry? What's that? There are two different terms. We have a sine in one term and we have a cosine in another term. How could we fix that? What have we just been doing? What did we spend like a half an hour doing on the... Right, we can use a Pythagorean identity for cosine squared and write it in terms of sine squared. So I'm going to write this first term as 2 times 1 minus sine squared x. So I have all my terms the same. This is our Pythagorean identity. Plus 3 sine x minus 3 equals 0. So now if I simplify, I'm going to have everything in terms of sine x. So I get 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. I'm going to simplify, rewrite group-like terms. I'm going to say this is minus 2 sine squared x plus 3 sine x. 2 minus 3 is minus 1 equals 0. Now, the second thing I don't like here is I don't like this minus 1 in front of my sine squared term. What can I do? Multiply everything by -1, because this side is just 0, so that nothing's going to change over here. So multiply everything by -1, and I can write this as 2 sine squared x minus 3 sine x plus 1 equals 0. It doesn't matter. My personal preference is not to have if I can do it, not to have the negative in front of the square term, but it doesn't matter. You can do it either way. All right, and now we're going to factor, just like we did before. So how is this going to factor? 2 sine x, and I have a sine x here. I have to have a 1 and a 1. And how do my signs need to go? Minus, minus. So there's my factored equation. So this tells me one of these two parentheses has to be 0. So 2 sine x minus 1 equals 0. or sine x minus 1 equals 0. This one tells me that sine x equals 1/2. This one tells me that sine x equals 1. And now I look at my unit circle and I figure out that sine x equals 1/2 at pi over 6 plus some multiple, or x equals 5 pi over 6. So for this one, I'm just looking on my unit circle, where is the sine of my angle 1/2? Where's the y coordinate 1/2? These two angles plus any multiple of 2 pi. Sine x equals 1 at pi over 2. Plus any multiple of 2 pi. So this one, almost like the first one, we just had to do a little bit more work with our identity before we factored and solved our equation. Questions on that example? All right, let's look at one last example and then we are done for today. Sometimes we have an equation that involves multiple angles. And it just adds one little detail to what we're doing. So our example is 2 sine 2t plus 1 equals 0. So the multiple angle, what I mean by multiple angle is here I have 2t rather than just t. Now the first parts of solving this are exactly the same as what we've just done. We want to get the trig function on one side by itself. So I'm going to say this is sine of 2t equals negative 1/2. I subtract 1, divide by 2. And this is where you have to be very careful. I look on my unit circle. The unit circle is going to tell me where 2t equals minus 1/2. So on the unit circle, I look for where my angle is negative 1/2. If I look on my unit circle, I see that the sine is negative 1/2. Let's look at our unit circle. Sine is the y coordinate. I'm looking for negative 1/2, so I end up at 11 pi over 6 and 7 pi over 6. Those are my two angles where the sine is negative 1/2. So I go back here and I say that 2t is 7 pi over 6 plus 2n pi, or 2t equals 11 pi over 6 plus 2n pi. And now I divide both sides by 2. So this tells me that t, because I'm trying to solve for t equals 7 pi over 12 plus n pi. And this tells me that t equals 11 pi over 12 plus n pi. So first I solve for 2t. First I solve for my multiple angle, if it's 2, if it's 3, if it's 4, whatever. Get my angle first and then divide by whatever I'm multiplying my angle by. And that changes my answer here. So rather than 7 pi over 6, I end up with 7 pi over 12 and multiples of pi rather than multiples of 2 pi. So that's the twist with multiple angles. Solve for the multiple angle first and then divide your answer, both parts, the angle and the multiple of 2 pi, by whatever your angle is multiplied by. Questions on that? Okay. Homework. There you go. And